Welcome to section 9.2.3. We'll be looking at annuities. So in this section, we'll be considering an account into which regular payments are made. So in the past section, we had one lump sum that we put in the bank and then we watched it grow. It kept growing and growing and growing, but we never added any money. Now it's going to be more complicated. So we have payments that are regularly made. Now, since each of these payments is made at a different time, it will stay in the account for a different amount of time and will incur a different amount of interest. So we'll need to keep track of when each payment was made, how much interest will need to be paid for each of these payments. So for each of these problems, we will get a geometric sum to evaluate. This is where the geometric sum is. We'll add up each payment with its interest to the next payment with its interest and so on. All right, so let's start with an example, example 9.3.3. Starting on January 1st, 2021, Jonathan invests $1,000 every month in an account at an interest rate of 6% compounded monthly. Assume that he does this until his last payment on December 1st, 2021. How much money will be in the account on December 1st after the last payment is made? All right, so he's making a payment for a full year. So let's look at a timeline here. This is January 1st. On January 1st, he puts $1,000. On February 1st, he puts in another $1,000. On March 1st, he puts in another $1,000, and he does this until December 1st. All right, let's put 3 dots where he puts in $1,000. Now you can tell that this one will be in the bank for longer than this one. So what we want is we want to look at this, see how much interest it incurs, and how much money we'll have on December 1st. So I have 1, 2, 3, 4, 5, 6, 7, 11 months. And so that's 1,000. 1 plus my interest rate was 0.06 divided by 12. I have 11 months. So that's the formula for compounded interest that I will get on that $1,000. So that $1,000 will be equal to this on December 1st, right? Because I have 11 months of interest. Now, the next payment will only have 10 months of interest added to it because it was made a month later. And so this one in December 1st will contribute 1,000 times 1 plus 0.06 over 12. How many months? Well, 10. And now I have 9 months of interest for that one. So that will be 1,000. 1 plus 0.06 on 12 to the 9, and so on. And then the last one, no interest at all. Let me write it like that just because it's going to make it it's compatible with the others. I have no interest at all because it's made at the right before I look at the bank account and determine how much money I have. And so I want to add all of these amounts. So I will, well, he will have, not my money. He will have, I'm going to add them up. Let me add it this way. That way that the powers increase, which is what we're used to. So 1,000, 1 plus 0.0612 to the 0, plus so on, up to 1,000, 1 plus 0.0612 to the 11. And if you notice, every time we multiply it by 1 plus 0.06 over 12. And so that means we have a ratio of 1 plus 0.06 over 12. So this will be first minus missing or next if you want, 1 minus ratio. So first is just $1,000. The next one would be to the 12, and then 1 minus the ratio. All right, so to plug it into the calculator, I kind of recommend that you simplify this a bit. It simplifies nicely here. In general, I don't want you to round it until the very end to make sure that you get the exact answer I have and round only when you have to round. But let me say I can put that in a calculator and you could try to see if you agree with me. I get $12,335 and $56. All right, so that's the amount that will be in his account on December 1st. So how much of the money in A would come from interest payments? All right, so this is the amount that's in the account. Jonathan himself would have put a big chunk of that. The rest will come from the bank. So we want to know how much comes from the bank. So I want to know how much Jonathan deposited, and then the rest would come from the bank. So Jonathan made 12 payments of $1,000. And so that means he put in $12,000 in the bank. Everything else comes from interest. So interest would be 12,335.56 minus 12 flat. And so interest is 335.56. Good.